So today we are going to continue with pandas. We started pandas last week. We're going to wrap up with pandas today. So this is what we're going to do today. We're going to wrap up with pandas today and then go into visualization a bit. And tomorrow we wrap up with visualization. I want us to start machine learning next week. Right, next week is going to be the 7th week, and that is I think um is going to be the 7th week. After which we're going to have the last week for the second month. All right, so after that we'll just have 4 more weeks to go. So we are basically rounding up with the program. We are almost done. We've literally gone fast. So I need us to start with machine learning as soon as possible because that is going to take a lot of time. I need us to not rush it at all because it's going to be a new thing to so many of us here. All these things we've been doing so far, pandas and the rest. Probably some of us were already into data science before now, so we might have come across it. But I am very sure majority of us have not been exposed to ML. So I need us to take enough time to dissect it and just help everyone here understand what it's all about. Yeah, so today we'll continue with pandas. Just have a glimpse on matplotlib and seaborn, which are the visualization tools we'll be using, and then go straight right. Tomorrow we're going to wrap up with the visualization tool, and then next week we'll kick off with machine learning. I just that is just a brief of how far what we're going to be doing moving forward. So we've done a lot, and I urge you to sometimes just try to trace back to where we started and look at everything we've done so far. Look at the topics we've done so far, and ask yourself, do I know this? Am I comfortable with this particular topic? Am I able to explain this to someone? Am I able to answer any question coming from this particular topic? So that is how you know if you are making progress or not, right? So at this point, you should be very, very, very comfortable with Python. That is not an excuse at all. You should not be making silly mistakes. Definitely, you make mistakes 1 or 2 times, syntax error. We are human beings, all right? But at least it should not be very, very much. It should not be something that would be out of your control, that you would not even know how to like resolve it, that kind of thing, right? So if you make a mistake, you should be able to bounce back because you understand exactly where the mistake is coming from. So this is the 11th session, and the 6th week, yeah. So this is the 6th week. We've come a long way, and we still have quite some journey ahead of us. So our projects would be, you are going to get a project in the 3rd month. I think the 2nd week of the 3rd month, you'll get your project, right? So that's why I need us to just speed up with what we are doing so we'll be able to like meet up with everything. And I was very glad that I was able to meet up with class last week. If not, it's actually going to be a huge setback for us. But thank God for strength and all of that. We're able to cover what we're supposed to cover last week. All right, so I'm quite discouraged by the level of participants at the moment. I'm just having 57 persons, 50 something persons, 58, which I don't know why, but anyways, we will just have to continue with today's work. So let's move ahead. So I'm going to be doing correction on the screen. Sorry, on the assignments quickly before we move on to what we have today. So I'm going to be sharing my screen right away. Well, let me write it yesterday. Anybody attend writing it yesterday? Let me know in the session, the live chat, please. Okay, all right, all right. Um, okay, I believe the session was impactful. I wasn't able to attend. I didn't know what was discussed in the session, but I believe we all gained one or two things. Um, just note that attendance is being taken for the session. All right, so attendance is being taken, so it's going to be part of your overall score. All right. So we have you can see we have the assignment. I've actually not graded everything yet, but then I'm just using this one to do the corrections. Yeah. Okay. So now I'll quickly go over this. I give us few questions. I think about 10 questions. Some of the questions took a very new format, right? Which doesn't have a general objective answer. That is just to test or to check how well you participated in class. So question one, I asked you to create a pandas series from a list of temperatures. All right, from a list of temperatures that are given here, and label the indexes as Monday till Sunday, right? And specify the data type to be of float 32. So I anytime I'm doing a correction, I always say this, that whenever you have a question like this, you always break that question down. You don't approach it holistically. You break it down into bits. So you approach it bit by bit. So the first thing you do here is to create a temperature list, which you can see here. And by the way, this is an assignment from Vincent Obaro. I don't know. I've not seen him in class before. Neither have I noticed him, but I just picked him the assignment so for correction. So shout out to you. All right. Now you have to create the list of temperatures that were indicated in the question, and then you also create a list for the different days of the week, right? Now I asked us to create a panda series. I know what you can use to create panda series, which is PD series, right? So very straightforward. You identify the first argument here will be your data. Second argument, it can be your index, right? And you have specified the list here. So you just pass it here, right, as the value, and then also the D type here should be of float 32. All right. Now you can print the series to see it. So this is basically what you're going to see when you print your series. So very straightforward. So it's just to test your knowledge on creating pandas series. So question two, the same thing. I asked you to construct a panda series with 20 numbers from 100 to 150, right? And create an index from 1 to 20 using np.a range function. So you can see here that there's a play with numpy and pandas, right? There's an interaction that I'm trying to bring about here. So you need to use numpy functions to create your data and then pass that data into your pandas function. All right, so to create 20 numbers between 100 and 150, the function to use is np.linspace, all right? np.linspace. So You do that here. You do that here while using this particular syntax that we've discussed, and then come also create your index. All right, using the same syntax and passing them into your pandas series class. So this is just straightforward, all right? Like very, very straightforward. So you'll do that. That is for question 1 and 2, creating series. So question 3 now is for data frame. So I asked you to create a pandas data frame with 10 rows and the following columns. So we have name column, state column, age. So basically you have 5 columns here with 10 rows. So what I mean by 10 rows is that each of these columns should have 10 values. All right. So in this case, name should have what do I call it? 10 names, right? States should have 10 states, so they should all correspond to 10 values. All right. So you come here, you would have to just populate each of them using dictionary, and I said your name should be the first. All right. So your name should be the first here. So you do that and just random values, and you pass it into your data frame, the data. And though I didn't specify you use any particular index, but you can, it won't take anything from your mark if you specify an index. All right. So now there is something I saw in some person's work, in someone's work. Yeah, you still used print for me. Like I mentioned this in the last class that you don't use print for me to display your data frame. You don't use print, and some persons still went ahead to use print. Just know whatever you see as your score is your fault, because I actually laid emphasis on it, that you don't use print to display your data frame. You use your display function, and some persons still went ahead to use print to all right, that's fine. So you display a data frame, and it gives you something like this with the columns here and also the rows. So you can see in this case, this index here is, if you want to include an index here, Vincent, if you are here, if you wanted to include an index, you drop this name, right? But in this case, I required a column to a name column in the data frame. So your index doesn't necessarily have to be the names again. You can just put your normal index, your default index there. But it's fine that you're actually trying out things, which isn't bad at all. So the next question here, question 4. Question 4, for your above data frame, write codes to print its shape, columns, and so the data frame you created here, I requested that you display, print out the shape, the columns, and also the data type. So this is basically what we're going to get. The first output here should be the shape, which is 10 by 5, which means it has 10 rows and 5 columns. And the second one should list out the columns in the data frame. All right. So you can see it has 4 columns, 5 columns here: name, state, age, weight, and gender. All right. And the last one shows the data type for each column. So yeah, so this is just exploring your data sets. Now question 5, I asked you here to add a new column, which is occupation, to the data frame you created already. So I showed us how to include a new column in the last class, so that shouldn't be an issue for us. All right, that shouldn't be an issue for us. So we can easily just use this particular syntax that I have that I showed us. All right, so we put the new name of the new column in a bracket here, and then assign the values of that new column to that particular column, right? And then we run it. It's basically just adds the new column. You can see here that added a occupation. right? It has added occupation to our added occupation to our data frame. All right. So that is it for question 5. Can everyone still see my screen? All right. Someone asked last week, if I can remember, that how can we insert a particular column in a particular index, like that we don't want to maybe insert it at the end of the data frame. We want to insert it at a particular index. Yeah, there is a function for that. All right, there's a function for that which is insert. So I'll just quickly show us. So if we come here and you, let's say, what's my dear name? Okay, let me okay, df, we have df here, right? Okay, let's just quickly run this code. So I just want to demonstrate how we can run insert columns. So I think user we created it here. Okay. So because of time, I will just quickly go over that. But this is how you do that. If you want to insert it manually, you come here and say df.insert the first argument to be the index location. So if I want to insert it in the second index, I'll say 2, right? And I'll come and the next value would be the column name. So I'll put occupation there, occupation, followed by what? The values. All right. So in this case, I might have the values equivalent to, let's say, all right, so something like this. So I'll come and say values. This is basically the syntax I'm going to use in including a particular column at a particular index location. So in this case, it is not just going to add it to the end of my, it's not just going to add it to the end of my, so it's not going just going to add it to the end of my data frame. It's now going to add it to the second location. Now, let me quickly do that. Now, where is this person? Name list is not defined. I'll do this index. Only that. All right. From here. Okay, so what I'm going to do now, I'm just going to come here and comment out this code and run this again. Come here and run this. So you can now see that occupation here. Occupation has been added to the second index, right? Instead of it being added to the end of my data frame, all right, is now added here. So if I count this index 1, right, index 2, and what? Sorry, index 0, index 1, and index 2. So if let's say I want to add occupation next to the person's name here, all right, maybe for better representation visually, I can just come here and put 1 instead of 2, all right. So if I add 1 here, it's going to tell me that occupation already exists. So you just try to rerun this thing again, all right, because it's permanently makes You can see here that we've now changed the location to be for it to be beside the name of the person. So you can see how we can do that. Very, very straightforward. So in case you're wondering how to do that, you can just use this follow this in there. Someone asks, so sorry. For question two, the question specifically instructed us to use np.arange. Where's question two? Um, Arrange to create the range, and in the correction now use. There are two things that you are creating here, Walter. There are two things that you are creating. You are creating. I didn't specify anything to use in this particular. I said construct a panda series with 20 numbers from 100 to 150. That's the first part. I didn't instruct you to use anything. This person decided to use linspace. You can use other methods to achieve the same thing. You can use the random.randint function, right? That you can also create that values for you. All right. We can use basically anything that can achieve this particular task here. It's fine by me. But when it came to the second one here, I asked you, and this is like another part, and create an index from 1 to 20. Now, when I specify that you use np.arange function for this particular one, that's why I usually tell us to break whenever we are attempting questions. We try to break them down into different parts, all right, so that we understand how to tackle each of them. So that is basically what you should do there. So you don't necessarily have to use linspace here. You can use random.randint function, which will do the same thing, but it will not give you in a sequential manner. It just do randomly at least, but the values will be between 100 and 150, and there will be 20 of them. So that is it for that question. So let's just move on. So now you can see how we did this now. So just take note, this insert function, all right, this is what we can use to just put our columns, new columns anyway. So question six, I asked you to create two series A and B containing the numbers 1 to 5 and 6 to 10 respectively. Compute the sum difference. So basically just performing arithmetic operations on your series data type. All right, so it's quite straightforward. All right, so just create two of them, label them whatever it is you want to label them, and go ahead to do these, compute these differences and print them out. So that's it for 6. So question 7, 8, 9, question 7, 8, 9, and 10, they are basically not code, involving code. So these are the just needed you to like read up some things and think about what we did, right? So that was the essence of the question. So question 7, I asked you to list 10 attributes of a series that doesn't excluding the ones we discussed in class. So there are a lot of them. I showed you, right? The aim of this question was to just push you to explore other functionalities, other methods, just for you, because it's a very good habit to learn on your own. So this is a prompting to do that. That's why I asked this question. So probably while you are doing it, you might be curious to know what that particular method can do, and you might try it out. So these are some things that we didn't discuss that are part of series functionalities, all right? Question 8, this one is for data frame. So you can see all these 10 of them here. I will have a lot of them. We might actually look at some of them. I think we looked at duplicated, if I'm not mistaken. Anyways, question 9, highlight 3 differences between a series and data frame. All right, you can see this, we're just here. Basically, this is the first one, structure, indexing, and usage. I love how this person answered this question. All right, very, very neat and nice. So question 10, mention two key points you learned from this. Is a very giveaway. If you have attended the question, then attended the class, it shouldn't be a problem for you, right? So that's it for the assignment. Please take note of where you missed it. The assignment is actually quite an interesting one. This subsequent week assignment would even be more interesting. Trust me, we are going to be doing more interesting things today and tomorrow, right? We'll be working with a real data set today. We are going to be working with a real data set today, right? So just buckle up and you'll definitely enjoy the class. So that's it for the assignments. Any question? I'll actually just if you have anything that you observe, please just notify put it down in the group chat. Let me see if we can quickly address it before we move ahead to the other things we have for today. Okay, for those of us that were not able to that are having issues with submission, um you know that I'm not even bothering to pay attention to any of them because I don't know. I'm not going to do that again. I'm not going to do that again. If your problem was wrong file formats, I'm sorry. That is going to be on you. You try as much as you can not to repeat the same mistake again next week, right? Because I've sounded this. Everyone here can bear me. We will bear me witness that I've consistently sounded this in the class and all of that. That you check your file before you submit. So um sorry about that. If I've graded the assignment already and you got a mark like that, it's something you should try not to repeat again next time. So I'm sorry, I'm not going to do anything about that. Okay. Um, I'm asking regarding this assignment, not another question from maybe something we've not done before. Please kindly explain how you move the occupation to the end part. What do you mean by end part? Like it's just normal adding a column to your data frame now. It appends it to the end of your data frame, right? And the insert is to just specify where exactly it is you want to insert or append or include the column in your data frame. Um that's basically what it is. How do we make names a heading when making it an index? You just pass the list, like just pass the list into the index. The same list you use for names, you pass it into as index rather. All right, so let's just go into what we have for today. There is no time. All right, so. All right, so let me share my screen again. Okay, so today we stopped here last week. I think we stopped at where did we stop last week again? I'm not really sure. All right, I think dropping. Okay, that is dropping of columns. Okay, I think we stopped here last week. That is data manipulation. So we're going to continue from where we stopped quickly. So let me just go over what we did last week. So we introduced pandas or looked at pandas series data frame. So for data frame, we specifically looked at um, the the common data frame attributes, shape, columns, index, data type, size, and all of that, right? I looked at data frame operations using the head or the tail function, selecting columns and rows, right? Using iloc and lock and all of like I went through all of that, and also Boolean indexing. So Boolean indexing is for what? So what do we use Boolean indexing for in pandas? Selecting data, select specific data with conditions, true or false for masking, comparison. Yeah, so Boolean indexing is basically used for filtering data. That is the correct word, filtering data. So whenever you want to select a specific filtering in data analysis is selecting a specific subset of your data based on a condition, all right, or that meets a certain criteria. That's what filtering is. So when you want to filter data in pandas, your Boolean indexing is a way to achieve that. All right. So you use comparison operation to make to specify the condition that you want your data to meet. All right. So we looked at that too. And we moved on to data manipulation. We looked at how we can add and remove columns. All right. So I demonstrated this in the last class. I also looked at how to drop columns, a column and rows actually. You can as well use the same format to drop column and row. So in this case now, this particular syntax will be used to drop a column. But if I want to change, if I want to drop a row, what am I going to change in this particular syntax that would automatically drop a row instead of a column? Exactly, exactly. We're all correct. So basically, you just have to change your axis from 1 to 0, and you ensure that this particular value that is here corresponds to your row. Like it's an index in your row. Understand? Like if you just change the axis here to 0, and you leave senior here, it's going to give you an error because once it searches the zero axis, that is the row axis, it's not going to see senior in the index, right? And it is automatically going to give you an error. So you make sure that once you are searching the row, you put a value here that will be found in the row. All right, so that's basically how you um drop a value from the row of a data frame. So that's basically dropping how to drop from values. So let's quickly do something. Let's quickly do something. So I'm going to jump straight to Redis CSV file, but I will come back here to look at all these things because I want to use the data that we read here to um to explain all these operations that we're going to be looking at here. All right. So let's quickly look at that. So now, I told us that there are several ways there are several kind of data we can use in pandas. So one of them is CSV file. CSV file is a very common file format. It's called comma separated value. So you mostly be interacting with CSV file as data scientist most of the time, or a data analyst. So the CSV file is going to be your major route of importing data, or this for particular method I'll be explaining will be your major way of importing data into your Python notebook. So how do you do that? First of all, let's just quickly go to so first thing first, we are going to importing wait. All right, importing necessary libraries. Okay, so I'm going to come here and import pandas. So in this case, we'll just be importing pandas from now as PD. All right, so run that. Now I want to import my CSV file. I need us to pay attention. All right, whenever I tell us to pay attention, is because I know already from experience that this usually is the major it would usually pose as a major challenge for most of us. So the same thing I said last week when I was telling us that we should use display function instead of print. I remember I think I laid emphasis. I either told us to pay attention to this, right, which some persons still didn't. Anyways, but this one now very very important. I pay attention to import a CSV file because the assignment I'll be giving us is involve you working with a file, a CSV file. So for you to import it, there are certain things that need to be in check or in place. Now you have a folder, right, where the file that you are working with currently, this Jupyter notebook, is stored in. Let's assume you created a folder called Youth Drive, Data Science Youth Drive, all right? And in that particular folder, you have another folder inside called assignments. So that assignment folder is where all the assignments that you usually do are downloaded into, right? So that is where you download all your assignment folder. So let's assume I give you an assignment, right? Which will contain a notebook with the questions. So you download your assignment into the assignment folder and keep it there. Now, I now give you another file, that is a CSV file that you're going to use for your assignment. Download that same CSV file into the same location as your notebook. You understand? So this is an example. You might not necessarily be using this format, this folder that I just mentioned, but anywhere your notebook is, make sure that your CSV file is inside the same folder. All right, because if it's not inside the same folder, you're going to have headache trying to import your CSV file. All right, so for instance, now this my particular folder, this particular notebook here, I'm going to show you where it is. It is in this particular folder here. All right, this is a folder. All right, now in this folder, this highlighted, this one here now, explanation sheet with this and all of this is in the same folder as my data set that I'm going to be working with now. All right. So in this case, I have several data sets here. So I'm going to be working with one of them. All right. So you make sure that that data set you are going to be importing or reading is in the same folder. If this, let's say for example, I'm going to be working with this customer bookings, all right, customer bookings.csv. So this customer bookings.csv should be in the same folder. If it is not here, if it is in another folder, you are going to have problem with importing or reading your CSV file in your code Python notebook, right? So I need you to put that at the back of your mind, please and please. Put that at the back of your mind, all right? So that is very, very important to note. Um, so please just give me a minute. Give me a minute. All right. So please, sorry for that break. I'm going to be sharing my screen again. All right. So now we're going to be working with we're going to be working with a particular data set, right? We're going to be working with a particular data set. So how do I import my data set? So I'll come here and just say df, all right? The same way I say df equals to pd dot data frame, right? In this case, it will be pd dot read csv, all right? So what is going to be in your as the argument is the name of your file. So this is another thing to note. Make sure that you get the exact name of that file, like exactly as it is stored in your computer. You get it and paste it. All right. So in this case, we're going to be working with retail transaction. All right. So let me be sure that I'm getting it right. Retail transaction dot csv. So this is what we're going to be working with, all right? So you see here that I've imported my data. If I make a mistake, let's say I added S in this transaction and I run it, it's going to give me an error. And now I need you to pay attention to this error. Whenever you run this particular code and you get this error, file not found, this means that the file name that you've included here, it is not in the same folder as your Jupyter notebook file. All right, file number, because what this particular function does is that it checks that particular directory, that folder, for the name that you've included here, and actually open that file and read it and pass it as a data frame. That is basically what it does. So once it looks at this name here and it cannot see any match in that folder, it's going to give you an error, and the error is going to be file not found. So if you have file not found error, please don't come to the group chat and start don't it's not a reason to come to the group chat to be asking questions, because it is basically a problem on your end. You need to identify the exact name of your data set here. All right, so that is basically how to resolve this issue. So that is just follow these things I've said, and you're not going to have any error. So you read your CSV file. All right, once you run this code, you already have your file read. So if you come here and say df dot heads, let's see our data set. You see that we have columns here. We have, I think, few columns here. We have customer ID, product, quantity, price, date, method, product category, and discount apply. So this is just the our data set. All right, you can now see what you are working with. So now there are a lot of things to be done here. All right, depending on the question that you are asked. Whenever before you are given a data set, you already have a problem, a business problem. You don't just get a data set for the sake of getting a data set. All right. If you remember our introduction to data science course, the first stage in our data science life cycle is what? Problem identification. All right. So you have to identify a problem that the business is facing. So after you've identified the problem, there should not be a provision of a data set that cannot be used to solve that problem. So in this case, let's assume there's a business problem that we just need to understand, or it might not necessarily be a problem. All right, maybe it might just be the business wants to understand the performance of their different products. All right, they want to understand the performance of their different products. So this is a data set that can answer that question. So once you get the data set, there are things you can actually do with it to get or generate those insights. So we're going to do some of them in today's class. So we are going to see the practical application of what we learned in the last class and some other new things. So first off, this head has showed me the first 5 rows of my data set. All right. So if I come here and say tail, you can see that it gave me the last 5 rows. So I can now see the last 5 rows. Okay, not bad, not bad. Now if I come here, okay, let me just let's do this together. Okay, I want to just sample maybe 5 random rows from my data set. What particular function am I going to use for that? Yeah, we are correct. So it's df.sample, but you have to put 5 in the bracket. If you just do df.sample, you're going to get only one sample, all right? If I run this, I'm going to get just one sample. So to get 5, I need to put 5 in the brackets. All right, so it's going to give me 5 samples. So this is just, you can see, if you look at the index here, you can see this is index 1000, 778, and the rest. If I run this again, it's going to randomly generate again. You can see 865, 407, 938. If I run this again, it's going to, so this is just a random selection of my rows. All right, so it's just part of the initial method of just understanding your data set to see what data you have. All right. So um in if you are working in Excel, you can actually see everything at a glance. All right. You just have to scroll up or sideways to just see it. But in pandas, everything is not present for you to be seen instantly. So you can decide when you want to see it and what parts you want to see and how much you want to see. All right. So you have control over what you're seeing. So almost everything you'll be doing is based on is not the exact way you interact with data in Excel that you do here too. So basically you load your data. First thing is to just use head to get the first five row, right, of that. And then next thing you would most likely do is to get the column names. In this case, you can actually see all the column names here. Like it's prominent. So you might not necessarily need to now want to get the column names, but sometimes you might still want to, right? And you might want to also change some things in the column. All right, but that is part of data cleaning. We're going to do that later. But in this stage that we are in now, we just want to explore um, our data to understand it. So the next thing we're going to be doing, we can just as well just come here and just print the column name so we can have it. So I'll come here and say print pf dot columns. All right. So you can see our columns here, customer ID and all of that. So yeah, this is our data set. So the next thing you most likely do is to like understand the data type of our data. So how do I do that? Come here and say, what function am I going to use for that to understand our data type? Exactly. df dot d type. All right. So if I run this, what's happening here? You guys are giving me wrong thing. No, it's not working. So once the D type is not working, where do your S go to? There's only one person that I've included S, which is Walter. So you should have your S there. All right. So your D type should have S, not just D type. So these are the small things that might lead to error while working. You can see that you have, if you remove this S D type, which at first glance you might be like, this is correct now, like D type, like I think this is what we've been taught when looking at the different attributes. If you run that, you give you an error, you might not start wondering, why what's happening, not knowing that there's actually an S D types. All right, not D type because you have more than one columns. So put S there, you run it, it gives you your data types. All right, so please take note of that too. Very important, very important. So, but me personally, I think there's a more better function for this that even give you a whole lot more info than just this D type function. So the function is called info. So this function actually just explains the entire data set for you. It gives you you can see the class, the type of the object. It gives you the range, right? You can see the range. It has 1,167 entries. This basically means it has 1,167 rows, all right? So we also have the range index. It ranges from 0 to 116. All right, ranges from 7 to 0 to 116. So we can see that we also have the number of columns and the column names. We have the null count, and we also have the data type. All right. So this is going to like give you a comprehensive overlook on your data. You can see each of the column here, and you can see it will even tell you at glance if there is any missing value. So what this non-null count means is it tells you if there is any null value in your column. So you can see in this case, we actually have some null values here. All right, you can see it's not because it is not complete. All right, you can see year to year. It's just transaction date, customer ID that doesn't have null values. So and it goes on to show us the different data types of our columns. All right. So the other information we have here is data types. So it summarized the data types for us. It said out of all the columns, three of them are floats, 64. One of them is int 64. All right. And four of them are objects. So usually objects are usually categorical variables. All right. So but it's when it's a general data type used for string values, right? So that is it, and it will lastly tell you your memory usage. So in this case, in our computer, this particular data set is using just 73.1 KB. That's a very, very small amount of memory. So you don't have to worry about your computer not having enough space, but there's some data type that will be so large that you are going to see are going to see a lot of a large size here, a large size. Let's say I might see 100 MB plus or even 200 MB plus here. So this is basically a very good summary of your data set. So once you get your data, first thing you normally do is to just get the head and see what it looks like, the columns, and then using this info function, you would get a very good summary of your data. All right, a very, very good summary of your data. So let's proceed. Hope everyone that's here, please confirm if you can still hear me and you can still see my screen in the group. All right, all right. That's fine. So the attendance would be sent. So just keep an eye for that. Um, our assistant, Mr. David, has been away for a while, so you might have noticed by now. So we'll be back soon, hopefully. So the attendance, the class rep and assistant would um take care of that. All right. So let's quickly proceed. Let's proceed. So this is basically what you're going to do. All right. All right. So let's move on. Let's move on. So now that we've gotten information, sorry for those um break break in I just needed to attend to some things. So let's just move on. So we have our information here. So we're now going to follow the what we have here with the data we've imported already. All right. So we've looked at handling data manipulation. So now let's look at handling missing data. All right. Or let's start from dropping data, removing a column and dropping a row. So in this case, we all right. Now there's something that I will always advise you to do. For the fact that you don't know what might happen to your data set, maybe you might be trying to do some things on your data set and you make mistake, like make mistake that permanently affect your data set. I always advise you to create a copy of your data, right? Create a copy. How do you create a copy of your data? You use this particular function. So use this particular function df. Okay, just name it df copy. You come here and say df dot what copy. So what this does is this particular method does that it copies everything in this data set into another variable. All right. So in case maybe you are working with this df and you made a mistake, you can always come back and recopy this. All right, back to the df, so you'll not lose um information. So you don't have to always rerun this particular import. All right, so you can do this, just bring it down here. You can do that at several intervals. All right, maybe you've already changed some things in your data set. You can now come after you've changed those things. You will now come here and just copy it, all right, at that particular point here and run it to copy it in that state that it was, and then you can now continue with your data. So you come here, you say you want to drop, let's demonstrate that we can drop columns in our data set. So let's look at the columns we have, df.head or df.columns. So you can see we have several columns here. We have customer ID, we have product ID, we have quantity, price, transaction date, payment method, product category, and discount applied. So we let's say we want to drop transaction date. We don't really want to use date for now. We are going to definitely come back to date, but let's just assume we don't need date in our data set. We can just come and say we'll drop date, dropping transaction dates. So I'll just come here and say df dot drop. Remember, we are still using our original df. We're not using this df dot copy. This df dot copy is in case we want to come back. All right. Let's say we messed up this df. We can just come back here and or we can just come back here and say df is equals to df copy dot copy. So something like this. So it will now copy the content it was in this place back into your df, and you can now continue. So you can do this at several intervals during your work. Sometimes you might be doing a lot of analysis that would be lengthy. So at different checkpoints, you can actually do this df.copy. So you copy it at different checkpoints. So you can have like a version history. It's like a manual version history of of your data set. In Excel, if you are used to Excel actually stores your data at different points in time. So let's say you lose your data, you can actually go back to the versions that were stored and restore it. All right, that is basically the same idea here. So you can actually also create these different versions at different points by using df.copy. So in case you messed up with your data at a particular point, you can just go back to the nearest checkpoint that you've copied that data and just retrieve it from there and continue your work. So you don't have to go back to the beginning and do all the things that run all the cells that you've run and all of that. So just make your work much more efficient. All right, so let's just continue from there. So I want to drop the transaction date column. So in this case, I'll say transaction dates. All right, so axis is in the column axis. So let's just look at that. If I run this, it should, okay, transaction date, not data. So you can see it has dropped my transaction date. Transaction date is no longer here again. So I'm now okay. This is what I want. I'm going to say in place in what? In place equal to true. All right, so this is going to make it permanent. So if I come here and display my data set, df.head is going to, okay, basically I'm trying to do the same thing again. So that's one thing about doing this particular operation. If you try to run that cell again, it has already dropped that column. So it will now try to drop it again, but the colon is no longer there. So it will not give you an error. So what you will do is just to come back here and do this, come back here and do this. So you can see that you come back here and do this that I just told you. So you see that because we already have a version history here, I can come here and see df is equals to df copy dot copy. So you can see let's more exact position. And, so I should have this. What's this one? Dot head. Here, copy dot head. What happened? Did you drop copy column 2? Oh, okay. I didn't know what happened there, but let's just continue. So this was supposed to. So you. So basically, you've dropped. So basically, you've dropped. Let's say we want to drop our missing values too. So I'm going to come here, right? So now we already know how to drop missing values in pandas using the drop. Who can remind us the function that we use for dropping missing values? All right. Drop NA. Exactly. So basically, we use the drop NA. But before we use the drop NA, we're going to quickly look at our data set to know if there is any missing value. So I'll come and say df dot is NA. All right. So I do this like this, it's going to just give me this particular um Boolean mask, whether true and false and all of that. So to get the particular number of missing values in my columns or in my rows rather, I'm just going to have to say sum of everything. So you can see that it will look through my columns, right? And check if any of them have any missing values. So the only one that doesn't have missing value here is my customer ID. All right. So product ID has 4 missing values, quantity has 2 missing values, price has 12 missing values, payment 5, product category 4, and discount applied 5. So we're going to look at how we can work around replacing these different columns, right? So remember we looked at how we can replace missing values or how we can approach missing values in the last class. We looked at 2 methods, which are either dropping them or replacing them with a value, all right? So in this case, we're going to undo each of the column individually. We would look at each column and see if we can actually replace the values. All right. But before we do that, there's something I quickly want to show us. Now, if you will see that our column here is somehow in capital letter, like it start with capital letter. So sometimes it might be difficult remembering some of these columns, all right? So it's very, very good that you try to, like, let's say, just format your column like by changing the names of your column or changing the casing so that it will be easier for you to call those columns when you want to call them, because most of the things you'll be doing subsequently, they would involve you referring to a particular column, so you don't just get bogged down by just repeatedly I'm calling a very long column. And like in this case now, we have this column discount applied, and you can see it even has a percentage sign. So imagine trying to type discount applied, like let's say 10 times throughout your notebook, and you are always looking for where the percentage sign is. So it's not very efficient. So sometimes it's nice that you actually rename some of these columns. So the way we do that is by basically using the rename function. All right. So I'm going to come here. I think just after this here, I'm going to come here and rename. Okay. After I've explored, I'm just going to come here and now rename our column. All right. So formatting and renaming our columns. So there are some cases or some instances where you don't need to rename your column. You just want to convert it to small letters, right? Because it's easier for you to work with small letters than it's easier for you to work with a consistent case. Either everything is in capital letter, everything is in small letter. So you don't have to be using shift and using caps lock and all of that. So sometimes you just want to convert everything to small letter or convert everything to capital letter. So in that case, when you actually don't want to rename your columns, you can just what you do is just come here and say df dot colons dot string dot. Now, what this string here does is that it gives your columns, because what this df dot colons here returns is list. It returns a list of all your columns. All right. So this string method here actually makes the column name in your data set that is returned here. It makes it accessible, or it gives it access to so many functionalities. They call it string functions. All right. So if you come here we can actually look at the different string functions by saying print df dir rather, and come here and just do this. You see that you have so many string functions. You have a lot of them here. You can see you'll be using some very common one. You can, in this case, we have lower, we have where is that? We have type 2, all right. We have strip, we have I think I'm looking for upper. We have upper here, as you can see. So depending on what you want to do, you can actually just use this particular string functions, right? So, and to get access to it, you have to, after you put your name your colon, you just come here and say string. Now then access the one you want to use, then dot lower. So what this dot lower do, it convert all the columns in your data frame or data set to lowercase. If I run this, you see that everything here has been converted to lowercase, right? Customer ID, you can see everything is lowercase now. So this is much easier. It's much easier to type customer ID all in small letter than to type customer ID with some of them having capital letter and some of them having small letters. So it just makes everything very confusing. All right. So this is basically what you can do sometimes. But you know that if you do this, it is not going to affect your original column. So you have to pass the output into your columns. So you come here and say columns equals to this. All right. So this is basically how you do it. So it takes the output of this particular code, which is this, and pass it to this df.column. So when you call df.column, as you did here, instead of getting all these things, you're going to get the newly formatted column names. All right. So that is one way to do that. The second way is by actually renaming your columns, by manually renaming them. So how do I rename them? You can just use df.rename. So what df.rename does is that it takes a dictionary of your columns. So the keys in your dictionary are usually the name of your old column, and the value is the new name. All right. So this is basically the syntax. So old name and what? New name. So this is the syntax it usually follows. All right. So this is how you rename your columns. So in this case, I want to rename some of my columns. I want to rename product. I want to rename product ID to be product. Okay, first I want to rename customer ID to be just ID. No, nothing like customer ID. So I'll come here and say customer ID. Remember, we are still using the original column that we have here. We've not converted it yet to small letters, so we'll still use the original one. So I want to rename ID to what? Just ID. And then you know how dictionary is right now. You come back here. So this one should be equal to, all right. So come here and say what do I want to rename? I want to rename product ID. I want to rename it to just prod ID. All right. So this is what I want to rename it to. So you look at your columns and the ones you want to rename. So I want to rename payment method to be method. All right, method, or let's say pay method. I want it to be as short as possible. That is why it should be payment method to be pay method. All right. So come here. Oh, sorry. These are not individual dictionaries. They are supposed to be in a single dictionary. not separate dictionaries. So it's just one dictionary, all right? So this is how it's supposed to be. All right. So I'll come here and have I'll have product category should just be category. Product category to be just category. So just be careful of your syntax here. I think there's some syntax error here. All right, so you just change it to category. And then the last one, discount applied. Okay, should be here. Discount applied with the percentage. So I can just easily change that one to discounts. All right, so this is basically how you rename your columns in a data frame. So if I run this, you see that it has renamed all. Oh, I didn't change quantity. So okay, what will happen is that I'm first going to convert everything to small letter. No, I'm going to rename them first and then convert everything to small letter. All right, so I'll come here and then say converting. All right, so I can just say df.head. So now you can now see what exactly do we have here. Okay, so I'm going to tell you what we've not actually assigned this yet. So if I come here, I'm just going to say df.columns be sure. Let me see it has in place. All right. So let me just be sure first. What is wrong with this? Okay. Let's see exactly. Sometimes Python can just be so unpredictable. But so we have this. This should be what we have here. All right. So we have df equals to this. All right. So df should be this, and if I come and say df dot columns should give me this, and if I say df dot columns dot string dot lower, and I come and say df dot head, should give me this. So you can see now that we've achieved that. We've renamed our columns. All right. So we rename customer ID to ID. So this is what you should actually do first before you even start anything. So once you realize that your columns are actually not how you want them to be, you can start by renaming them. You can do that manually. It might not be everything that you will rename. You might just look for the particular ones that you want to rename, right? And then rename them. So I think I might want to even rename the transaction date here. Transaction date. Message transaction date. All right. You all should see the get the attendance now. Sorry for the delay. So the attendance has been posted on the. So the attendance will be posted now. So the class rep will post the attendance now. Just do well to fill in your name. All right. So I'm going to just change this to date. Let me change it to date. All right. What do we have here? What exactly is wrong with this notebook? I think there's something wrong. There's something wrong. Anyways, don't have time for that. So this is what you have to do if you want to format the columns of your data set. You can see that it has been shortened now, so you can easily reference them without typing out the long things that you've been used to already. So you can just come here and run all these cells that I have run. So instead of typing out the transaction, then just you can see how short it is now. Alright. If I this, how um you see how short these things are. So it makes it easy for basically it makes your work very much easy. Okay, so now we can now start looking at all the let's drop this transaction dates here. All right. So you can now start looking at the different columns. So we can see that the product ID column has 4 missing values. All right. So if I come here and say df dot prod ID, so basically it is a categorical variable. All right. It's a categorical variable. So what am I going to use in this case to repopulate this variable? Since it's a categorical variable, how am I going to repopulate this variable? All right. So because of time, we're going to basically look at the category that is most present, all right, the most frequent category in this variable. So to get that, we are going to use mode. That is, I think, should be mode, all right. So you can see that the most frequent common category is category C. You can as well just assign that to, let's say, mode here. Now to handling, so we're looking at how we can handle missing data. All right. So we'll handle them one after the other. We'll look at each of the category or each of the variable and look at how we can populate or replace the missing value. So for this one, I'll just come here and say df and say mode. I'm sorry, prod ID. and say dot fill NA, and I'll say mode. All right, so basically this is how I'm going to handle that. So if I come back here and say df dot um let me see. Okay, so I'll just basically have to put in place here so that it becomes permanent, but I'm not going to do that yet. I want to do it for everything, all the columns uh that have missing values. All right, so I'll come for the second variable here, which is quantity. Just take a look at quantity and come and say df dot quantity. All right. So you can see the quantity is a floating point value. All right, they are floating point value. So we use our mean to just replace the missing values we have. We have two missing values. All right. So I can just come here and do the same thing here. I would say df quantity dot fill NA. I'm going to get the main here, main quantity, and say df dot. You can see I'm using two different methods of referencing the variables. I'm using the dot and the bracket. So anyone that you want to use, so you can just use either of them. Quantity dot mean. All right. I'll come and say mean quantity. All right. Come to the next one. The next one here is price. So I think price. So to just save us time, we can just look at data types. Come here and say df dot d types. D types. All right. We're going to see. So price is a float. So we'll just do the same thing for price here. Do the same thing for price. Come and replace this with price. Come here and replace it with price. You can see that we are handling the missing values individually, like individually. So the next one here is what? Payment method. So payment method has five, okay, it has missing values. We have payment method. Okay, we have another floating point, which is discount. So let's just quickly do for discount. So since it is a numerical value, so I'll come here and say discount. All right. Come and say discount. And say discount. And come here and say discount. So that is for the numerical value. So for the categorical values, we have P method and category. So we're going to do the same thing we did here. So we're going to just copy this from here, come down here, and I think P method. All right, P method. Just copy it. Put it here too. And put it here too. Copy the same thing. And then come here. I think we have category, right? Category. Just copy it from here and put category. Are we all still following? Hope everyone is still following. Put your category here. So in this place, I can just put broad. So what we've done now is we've handled the missing value for all the variables here. that has missing data. So this is one way to handle missing value. You can actually do that individually, or we can just come here and just say df.drop na, finish. Like it will automatically just drop all the rows with missing value. Do you understand? So this is this is how we can handle it. This is the first way we can handle it. This is the second way we can handle it. So if you have a lot of data, like plenty data, you can as well just use drop na, and the number of missing values are not really plenty like that it will significantly impact the number of the size of your data set. You can just drop them. But if you don't really have plenty values, plenty data, just go for this second option here. So if I run this, it should automatically um um you automatically fill in all the missing values. But what is going to happen here is that we've not added in place, so it has not done it has not permanently affected our data set. So to do that, we'll just come to this fill NA and add in place equal to true. So I have to come here, just copy it, just copy it from the format here, copy it here, copy it here, copy it here, copy it here, and copy. So if I run this, all this thing is just warning, all right? So if I come here and run this, you can see that it has removed. Okay, let's see which one it didn't before. You can see that it has removed or replaced the missing values for quantity, price, discount. I don't know why it didn't before this other ones here. Let me see. Mm, So the numerical replacing numerical variables missing values with their names. Alright, so this one is replacing categorical variables missing values with their modes. Alright, so let's alright, so it should automatically. There's something wrong with this notebook. I don't know why, but there's something wrong with this notebook. It's just giving me issues. But once you follow this code here, it should replace all the missing values for all the data sets that you have already. That is basically what it does. So once you rerun this your code here, to compute the missing values, everything here should be zero, right? Everything here should be zero. Same thing for this other method, which is drop NA. You come here and drop NA, and you'll say in place equals to true, right? And come here, it should or you can see it now that everything should be equal to zero. All right, so this is what you get, and this is what you are trying to achieve when you are trying to like handle missing value. You want every variable should have zero 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 zero. All right, so whether you use this first method, which is dropping, just dropping it straight away, or you use the second method, which is um which is by replacing the missing values either with the mean, right, or with the mode. So you can use either of these two methods for handling your missing values. So I will still have to check what the problem was this with this particular code here, because um I don't understand why it didn't replace those values. So you're asking, someone asked why I used, yes, it's depend on the values or the data type you're working with, right? If you're working with numerical data type, you can't it's best to use the mean, because the mean is a better representation, right? Why for your categorical variable, the mode is basically a better representation of, like, it tells you the one that is more frequent, right? So the missing values, they have higher probability of being that value that is more frequent. All right, so it might not be entirely correct, right? It might not be entirely correct, but you are more accurate when you use the most common value as a replacement than when you just use random values. So but if you're not really confident with replacing it with those methods, you can as well just drop everything. All right, you can as well just drop all the missing values. The thing that will happen, it will just reduce the number of your data, like the size of the data sets, right? So that is what it does basically. So that is for handling missing values. So you can as well just come here and let's see if we so df equals this, this, equals this. So let me prepare around this here. All right. And do on this, around this, okay, around this. So I'm going to run this method. Oh, what did we do? Yeah, what did we do? She said this notebook is has an issue. Anyways, alright, notebook is this. Okay. Um. Oh. Okay. I'm trying to see if we can fix this. Hmm. All right. So um, that should be it. I still don't know why this though that shouldn't take our time. Let's just move on to the next thing. Yeah, we'll come back to that hopefully. So we've just looked at handling missing values and dropping also missing values. Now this should already give you a glimpse to what it looks like working with real data. So real data is very unpredictable, right? We don't really have a pattern to follow. Definitely, there is a general there are stages, right, that you follow while analyzing data. You import the data, you explore the data, you check it out, you clean the data, right. So what we are doing now is cleaning the data, right, by formatting the columns, um um by removing missing values and doing a lot of other things, right? But it depends on the data you're working with. So your some data might be so unpredictable that some things that you might actually have to do, right, that you will not do with another data set. So just give you an idea. That's why I needed us to explore or to demonstrate with a real data set. So this is exactly what it looks like. Um, Cleaning your data set. So, and if you've seen this before somewhere, you would know that data cleaning takes most of the time in data analysis. Once your data is clean, your work has been done basically, right? Your most of the majority of your work has been done. So you just have to go ahead to just do your analysis. It will be easy for you. It will be like a smooth ride for you. So the bulk of the work is in cleaning your data, is to making and ensuring that your data is in the right shape and format. Remember what we always say about garbage in, garbage out. So if you don't have a clean data, your insight that you're going to be getting or your analysis will be also garbage, right? If you have a very clean data and a well formatted data, your analysis would be very, very nice. The insights would be very useful and practical. All right. So it's essential that you understand this thing and you know that okay, you need to pay more attention into getting your data set right, into getting it right. When we start machine learning, we're going to look at a different step that is called pre-processing, right? We're going to be doing a little bit of data cleaning there as well, but it will also involve us changing some of the formats of our data. So these data manipulation techniques and this data cleaning and all of these formatting methods are things that you need to know how to do well. All right. The analysis part is quite straightforward, honestly. It's actually quite straightforward. We're going to look at it. We're going to actually look at it. So let's just proceed. So we have what we call data aggregation and group operations. So this part is the part where you now start deriving insights from your data. All right. In data analysis, we have what we call bivariate analysis and univariate analysis. I'm going to say it again. Let me just write it here. Um, we have types of analysis. We have univariate analysis, and we have bivariate analysis. So univariate analysis is when you are analyzing or working on just one variable at a time. All right. Why bivariate is when you're working on two variables together. All right. I'm just going to take you through some of the techniques that you'll be working with while doing these things. So let me bold this because I always love to bold my headings. All right, let's bold this as well. So we have this, we have univariate analysis, and we have bivariate. And so for our data set now, let's just bring it up here. So we have this data set, right? We have all of this here. We have the production ID, quantity, price, payment method, category, discount. So there are a lot of things we can derive from this, right? We can either start to analyze each of the variable individually, or we can analyze two variables at a time to check for relationships and how one variable is affected or affect another variable. What do I mean? So for instance, now let's just quickly look at one variable. Let's look at production ID. So I'll come and say dev and say prod ID. All right. So I want to know which particular category here was the most, or the which of this category is the highest, basically. All right. So to do that, you basically have to use what we call value. Let me zoom in a little bit. Use what we call value count. I believe I've explained this before. We use what we call value count. Now, there's something you will notice. When we are doing univariate analysis, we are actually working on a series. So remember I told you a series is a single column in a data frame. When you are actually getting or retrieving a single column, that column will be returned as a series. So everything you can perform on series object, you can perform it on that column. So in this case now, we can actually get the values count of this particular column, which is product. So we would get the different categories in this case. Even before we do that, so let's comment this out. Before we do that, I want to know the unique values. All right, we want to know the unique values in this particular variable. So to do that, you just come and say product. So these are the things you should be learning, the different functions. Product ID dot unique. All right. So what unique does is that it returns the unique values in that particular column. All right. So in this case, you will see that we have B category, C category. So we basically have 4 unique values, and you can see that we have missing value here as well, which has not been dealt with. So you can see it gave us this. If I come and say, let's say which other column do we have there? So you see that you can easily forget your column. So it's very essential that you have them nearby. So I want to look at the pay method. So you use this unique method for mostly the categorical method. So for your pay method, you have one cash, and you have cash, credit card, debit card, PayPal. So basically you have 5 or 4 unique values or 4 different payment methods. So you're already having an idea on the different categories of your data in your data set. All right. So you can come and do the same thing for category. So I can come and do the same thing for category. All right. So for category, you can say we have clothing, we have home decor, we have electronics, and we have books. So we have 4 of them as well. All right. So you can see that you now understand the different unique values of your categorical variables. So let me just print this out here. So when you are reading the material, you understand what we were doing. So this one is prod ID. This one should be pay method. All right. So now we can actually get the unique value, the number of unique values as well. So if I come here and say df prod ID and say n unique. All right. So what this does is that it, instead of returning a list of all the unique categories, it just gives us a number, and that number tells you the number of unique values that particular variable has. So in this case, this variable, which is product ID has only 4 categories, right? If I come here and say pay method, you see it's same thing for. So without us knowing
specific categories, we already know that okay, this particular category has 4 unique values. If I want to know the unique values of all my variables, I'll just apply the unique and unique to my data frame, right, and run it. So it will just return everything corresponding to each of my to correspond the unique the number of unique values to each of my columns. So you can see in this case, my ID obviously is not unique. So basically, everything is unique in a sense. That's why it is called the ID. So the product ID is 4, quantity is 10, price is a lot of unique values. Pay method for category for discount. So you can now see where we are headed, right? You are now starting to understand your data. You can now see that okay, some of my data sets have so number of categories, and now we can now start to work on those categories to know which of the category is more in my data set. So now we can now start performing univariate analysis, right? So univariate analysis is basically when you look at each individual variable, right? And asking question like which particular category in this for categorical variable, which particular category has the highest frequency. For numerical variable, it can be what is the mean of this variable, or what is the highest value, or what is the lowest value, or what is the range, or a lot of things that pertains to just one variable. So any insight or any information that you can get from just one variable, it is under univariate analysis, right? So you're just analyzing that one variable to get insight from it. So let's just look at a few examples. So let's say for this particular categorical variables, we're going to look at category itself. That is df category. And I want to get the unique values from each of the categories here. What I'll do is just use value count. Sometimes I forget where the S is. I don't know if the S is here or here, but let's see. So you can see that it will return the unique values or the number of time each of the category appeared. So you can see that the one with the highest value is electronics, right? Having 404 occurrences in our data set. So I think based on this, you can now start saying that okay, most people actually purchased electronics products during so and so time. You understand? Or less people that purchase clothing were actually very very few. So from there you can now start to make draw conclusion that maybe it's because clothing are expensive, and that question, that assumption alone or that conclusion can actually lead you to actually embark on a new analysis. All right, it can make you to start even collecting new set of data, all right, and performing new set of analysis. So data analysis is usually it's not something that you do and conclude like based on one analysis. It is a series of questions that lead you to a very solid conclusion. All right. So it depends on the question that you are asking. So this is not a data analysis course, so we're not going to go into all of that, but I'm just giving you an idea on how you approach on some of these things. So there's something we call 5 whys. I don't know if some of us should know it. 5 whys. So 5 whys is basically a means of inquiry, right? Maybe you want to get the root cause of a problem. You ask why 5 times, all right? So let's assume you have this particular result. Your clothing, the number of people that purchase clothing product were just 84. You now ask why. That is your first why. So once you ask that why, you might now, maybe based on the new data you collected, the new data showed that the clothing are expensive. That is why. So until you get to a point where you can no longer ask a question, you've not come to a solid conclusion yet. All right. So let's say you now get that data and answer that question. Another question now arise: why are these clothes expensive? All right. So you now, if there's a need to collect more data, you can collect more data and start making inquiries on why these clothes are expensive. So it might be because of this material and this material are imported. You cannot say, okay, why are these materials imported? Okay, they don't produce them in this. So this is basically data analysis for you, right? It is a field of curiosity, of asking questions, right? Of making sure that the conclusion that you are coming to is a very, very solid, um, very solid conclusion, all right, that is backed by data. So I'm just giving you an overview of data analysis generally. So you should have at the back of your mind, all right? I think there are some questions I'm seeing here. Everything look like magic. What exactly, please? What exactly do you not understand? Because I believe we've been taking it quite slow. Anyways, the video will be available for you to go through at the end of the class. So basically, this is how you perform univariate analysis, right? You can use value counts, and in this case, if you want to see them as percentages, you can just come here and say normalize and say equal to true. So the values count method takes in an argument called normalize, which can be set to true or false. So by default, it is false. So normalize convert it to percentage. So you understand it like in a form of percentage. So if I come here and run it, so that it will give me this particular it will give me these particular values. You can see 0.37, 0.34, 0. So these are percentages. If I multiply it by 100, I think it should be outside or inside. If I multiply it by 100, you see that you can now see this is a percentage. So 34.73 is the percentages of those that purchased electronic equipment. 32.76 is and 7.22. So you can now see that you are now starting to derive insight from your data. All right. So based on the question that you are trying to answer, you can now start to use this information you are getting to answer those questions. So this is univariate analysis. All right. This is univariate analysis. And this is for categorical variables. So to perform univariate analysis for numerical variables is actually very straightforward. So as I said, univariate analysis, what are some examples of some analysis you can perform on numerical variables that are univariate? I mentioned that earlier. Can someone remind us, those that have been paying attention? Exactly. So examples of univariate analysis, mean, median, mode, and all of that thing that you can use to get the statistics. So remember we did all the statistical function that we looked at previously in previous classes are some the functions you can use to perform univariate analysis. So if I come here and say df price, I want to know the highest price, that is max, or let's say mean. I want to know the mean price, all right? I come here and I'll see I'll get this value 95.03. Let's say it's in dollars. So $95 is the mean price or the mean price of my product, all right? So if I want to get the max, I can come and say max. So the maximum product that was purchased, or the maximum price of a product that was purchased was $17,000. You can see it now. Why the minimum is what? $2, right? So these are the things. Okay, let's look at discounts. Let's look at discounts. So discount, the minimum discount was 0, the maximum discount was what, 24, while the mean discount was what, was 11. So these are the things. So there are a lot of things you can do, but depending on the question that you are trying to answer, you would use specific functions to answer this question, and it will make a lot of sense when you start using these things to answer specific question. All right. So when you get your assignment, you're going to see how to do or approach it in that particular way. So this is univariate analysis, basically performing analysis on one variable at a time. All right, one variable at a time. So let's go straight. Let's go to bivariate analysis. Bivariate, performing bivariate analysis. So bivariate analysis now has to do with two variables, right, being analyzed at the same time for to assess relationships and a lot of other things. Right? For numerical variable, the most common bivariate analysis is usually correlation. All right, is usually correlation, and correlation is a statistical technique used to assess the relationship of two variables. So for example, now if I come here and say I want to see if maybe the price or the quantity of my product is affects the amount of discount that is being given. Because in this case, in this my data set, I have quantity, all right, and I have discount. So I want to know if quantity correlates with discount. Maybe the higher the quantity I buy, the higher the discount given to me, or the lower the quantity, the lower the discount. So these are examples of bivariate analysis, questions that can be answered using bivariate analysis. And that question can be, which of the following payment method had had the highest average price, right? So which payment method do people use mostly, right? We've answered that one already. Now we can now ask, which payment method was used to make the highest average price, right? So we are going to assess the relationship between this payment method here and price to answer that question. Or we can say, which particular category of products had the highest average price. So we can check to see if clothing is the one with the highest average price, or home decor, electronics, and all of that. So these are the things that we can actually do in our analysis, either univariate analysis or bivariate analysis. So we will be these dates, we are just going to pause on date for now, because there are a lot of things we can do with dates. All right. Dates, working with data pandas is a different thing entirely. As we are going to look at matplotlib tomorrow, we're going to also look at date as well. But for today, let's just quickly look at bivariate analysis on two variables. So let's look at, or let's assess the relationship between payment method, or rather product category, and price. All right, assessing the relationship between product category and price. So how do I do that? You perform bivariate analysis using group by function. All right, you perform bivariate analysis using group by function. As you can see here, you use your group by function to perform your bivariate analysis. So how do I do that? What do I mean by that? So if I come here and I say df dot group by, what this mean here, or what I'm trying to do is that I'm trying to group my entire data set by a particular variable. All right. So in this case, I want to group it by the product category variable. right? So I'll come here and say group by category, all right? And the particular the corresponding variable I want to compare it with is price, all right? So I'll just come here and say um price. This is syntax you and you say mean, all right? So you can see here now that we've actually performed bivariate analysis, that is comparing the categories with the price in our data set. So if you look at this result now, you see that these values that we are seeing here at the right hand side is not the same value that we saw here. This value that we have here is the count, the what I call it, the count, all right, the percentage rather of the frequency of these categories in our data sets. So this normalized true actually converted, but without this normalized true, we're just going to get the count. So if you count electronics in our data set, we're going to count it 404 times. If you count books, we're going to count it. So that's basically what this value is. But for this particular one here, this value corresponds to the price. So now you're now comparing the price of each category. So now you're bringing two variables together and making that comparison. That is what we call bivariate analysis. All right. So based on this, now you can see that this particular result here is the mean. So in this case, we are using the mean as the aggregation function. We can actually use other. We can use sum. We can use any aggregation function that I've taught us, right? But in this case, the sensible one to use is the mean. All right. So this one is what we are going to be using here. So basically, the mean here shows us the average price of each of the categories. So in this case, the electronics category is the one with the highest average price, which is $170 on average. All right. So you can now see that you're now deriving insights little by little and understanding how your different products are performing in terms of price. So let's change it here. Let's look at the discount. Let's compare the category with discount instead. Let's say discount. So you can now see we are now having a different value, set of values. So these values here correspond to the discount. So the category with the highest discount was still the same electronics. So electronics was actually the product category in our business that we had the highest average discount given. All right. So in case you are asked that question, which of the product, maybe your boss is coming to wants to know the particular product that has the highest average discount that they've been, let's say they've been giving discount for like 1 year now to almost all the product line in that company. But your boss wants to know, they don't really understand or they cannot really keep track of it. So they need you as a data analyst to find this or figure this out. So by just doing this thing now that I've done, you can just get this value and say, okay, oh, sir, I've gotten this. So this actually is the electronics department is the department that have been given the highest average discount for the past 1 year. And so these are the things that you can be getting from your data. You can glean a lot of information, trust me, right? But just make sure that you are following the question that is being asked, or you are following the problem that you are trying to solve, so that you don't just move around and just waste time on a lot of irrelevant things. So this is bivariate analysis. All right, now you've been able to compare between two different categories. All right, two different categories or variables, sorry. So we've looked at univariate analysis, we've looked at so now this is the analysis part. With this part that we did here is basically just data cleaning and making sure that our data is in the right format. All right. So after we've cleaned our data, we can now move on to this is what we call exploratory data analysis. All right. Exploratory data analysis. So if I come here, I would say exploratory data analysis. If you look at the heading of this class, the title of this class, you see that is EDA. All right, EDA is a short form for exploratory data analysis. At the beginning of this program, I actually explained this to us. I told us that okay, this is the stage where you perform exploratory data analysis. So all these things that we are talking about now, they are all part of exploratory data analysis. And under exploratory data analysis, we can have these types of analysis. We can have perform univariate analysis. We can also perform bivariate analysis. All right. So that's actually it, right? These are the things that you'll be doing mostly. So there are a lot of things now that you now learn under each of this category. That is the bivariate analysis and the univariate analysis. So we have the correlation, right? We talked about correlation earlier on, where you can check the strength between two variables, right? Hope everyone is still following. Hope everyone is still following and everyone can see hear me. Okay. Okay. All right. Okay, great. So I said we can use correlation to check the strength of relationship between two variables. So for instance, now I want to check the correlation between price price and what discount. All right. So what I'll do is just bring my price here. So this is my price variable, right? Dot core. So dot core is actually a function that computes the correlation score between two variables. So let me put the other one here. Let's say discounts. You can now see why we make sure that our column names are short, because almost everything we'll be doing since require us to be calling our column names so that it will be easy for us to do that. If it was long, if this discount was still the discount we had before, it will be something like this: discount applied, and then with your bracket. So you see how hectic it is just typing all this whole thing. And let's say you want to type it like 3 times. So instead of doing that, you just come here and just type discount. So if I run this, you see that I'm getting a value. I'm getting a value 0.0498 and all of this, right? So this is a correlation score. Correlation score is usually between -1 and +1. Let me put it here. Correlation score is usually between -1 and +1. All right. -1 indicating very strong negative correlation, while +1 indicating very strong positive correlation. So these are the two. This is the range in which your correlation value can fall in. So in this case now, we have this value 0.04. So based on what I just explained now, how can you interpret this value here? Can someone just tell us in the group chat, how can you interpret this value based on what we've explained here now? Nobody's saying anything. What do you mean by what do you mean by average correlation? Correlation cannot be average. Is either weak or strong, or positive or negative. Yeah, someone said price and difference have a positive correlation. That's true, but it's not the complete. It's not entirely correct. Okay, someone said Musa weak correlation. Ismaila weak exactly. Ismaila said weak positive correlation. Favor said very weak positive correlation. That's the answer. So in this case, you can see that the value for this correlation is 0.049. So, and I told you that the value for correlation is between -1 and +1. So if the value is in between zero, okay, let me even put it to yourself. Zero means no correlation at all. All right. So zero means no correlation at all. So whenever you have a value that is between around zero, like 0.00000 something, 0.05 something, 0.000, just know that there is almost no correlation, or there is a slightly based on this one, the correlation is slightly positive, slight a weak or a slight positive correlation. Understand? That's how you explain it. That's how you explain this kind of result. All right. So in this case, you can say price has a very weak correlation with discount. So let's change it now. Let's change it to quantity. Let's change price with quantity. You can see the same thing, 0.04. Let's remove quantity and let's put what do we have again? We have what are the different, we have discount, price, quantity. Let's put discounts. All right. So in this case, how can you explain this particular output here now? You can see minus at the front here, right? Minus 0.2 is minus 0.021. What does this one mean now?
Exactly. So let me explain what negative correlation mean for those of us that does not understand. So negative correlation is when something is increasing, the other one is decreasing. You understand? That is when there is a negative correlation. As one is increasing, the other one is decreasing, right? That is what negative correlation is. So in this case, as discount is increasing, quantity is what decreasing. Or as quantity is increasing, discount is what decreasing. Do you understand? That is basically what how you interpret this. For positive correlation, as one is increasing, the other one is increasing. Maybe as price is increasing, discount is increasing. As quantity is increasing, discount. So that is what positive correlation is. You understand? For no correlation at all, as there is no relationship at all. You can't even see any pattern in increments at all. So when we look at visualization tomorrow, we are going to introduce a particular chart that you can use to visualize correlation, and you can use to visualize relationship to help you see the relationship itself. So in this case, you're not just using number to interpret, you're actually now seeing it for yourself. All right. So yeah, this is basically some of the things you are going to be doing while analyzing your data. So you need to get familiar with them. So we've looked at some of these things. We've looked at univariate analysis. We looked at bivariate analysis, right? And we've looked at in bivariate analysis, we looked at group by function, which is used to group by, which is used to aggregate a particular value based on certain categories. All right. So you looked at that one. We've also looked at correlation as well, right? So which is for numerical variable. So let's just proceed. We will be rounding up soon. We've actually taken a lot of time. So now we've looked at this already before. We can just, this is for univariate analysis, right? Print, maybe you want to check the mean of a particular numerical variable. You can just use this particular syntax. So for date and time, we are actually going to be looking at that later on. It might not even be tomorrow because yeah, we'll try to look at it tomorrow, but it's a special kind of data in pandas. All right, it's a special kind of data actually in pandas, so we're going to actually look at it. If I'm not able to finish up with it tomorrow, then next week, because I need you to understand how to deal with date and time in pandas. So we're going to dedicate let's say an hour or so on that. All right. So yeah, I think that is it. So we can also actually merge data frames, right? The same way we can merge series, and the same way we can merge other data structures that we've looked at, and we'll do that using the merge function. All right, using the merge function. So this is not something you'll be doing very frequently. All right, unless you have maybe your data set was split and divided into different subsets, and then you have to import all of them separately. All right, and then you can now use this particular merge function. All right, so this merge function, basically what it does is that it merges. What it does, okay, let me see if we can if there is a data that we have here that we can quickly use. All right, but what it does is that it basically takes, as you can see here, it takes two data frame as argument. It takes the first one as argument, takes the second one as an argument, and then this on keyword tells the particular function that, okay, well, you look at these two, because they have to be something in common those two data frame would have for the merging to occur. You can't just merge two different data set, because it's going to be chaotic, basically, to just throw you errors. So you have to ensure that the data set is similar. Maybe in the process of importing it, there's someone divided the data set into different parts. So we now imported it to pandas, and you now want to just join everything together. All right. So you can now use this particular function and indicate the colon that is common in both of them, and then pandas is going to merge it for you. So you can actually try it on your own. You can try it on your own, but it's not something, trust me, it's not something that you do very often. You might not even do or come across this particular depending on what you are doing, right? So just have this at the back of your mind. So the function is pd.merge, and it takes two arguments, the first one, which is first data frame, and the second data frame, and also the criteria for merging. All right. So yeah, that is it for that. So basically, I've introduced us on how to read CSV file, but it's not just CSV file that we can read in pandas. We can read a lot of other file formats. Let me just show you. So if you come here and say pd.read, and I press tab, you see that you see a lot of things here. pd.read CSV, pd.read Excel, like a lot of things, HTML, JSON, Packware, PKL, SAS, SPSS, SQL, like a lot, like you can read a wide variety of data sets. So the reason why we use read CSV is because CSV is the most commonly used data set. So you mostly not even use any of all those data sets that you just saw now. But just so you know that it can as well read other file formats, right? It can also read Excel format. Let's say you have let's say Excel workbook. All right, you have Excel workbook. You can actually read Excel and specifying the worksheet. If you're familiar with Excel, now we have worksheets inside Excel. Specify the name of the worksheet that you want to particularly import. All right. So these are the things that you can do with pandas. All right. So we can do that, read from different data sources, and we have parameters as well, which should also not use most of the time, but it's also nice that you know about them. You can specify the data type for each column, as you can see here. And so yeah, this is basically it for today's class. So let me just go straight or take you through the different stages that we are going to be working with typically, right? The first stage is data acquisition and loading. This is the first stage where you initially acquire your data, right? Which is the importing with CSV and all of that. Second stage is data exploration and understanding. So this stage is basically is not the same thing with exploratory data analysis. So this is just understanding your data set. This is where you use your head, dot info, dot describe, dot shape, all those things just to at least get familiar with your data set and the structure, right? So the next thing is data cleaning and preprocessing, all right? So this is where you now start to handle missing data, you handle duplicate data and all of that, all right? So I've showed you how to drop duplicates as well yesterday's class. So you just apply it to today's data set. After that, next thing is to perform EDA, perform exploratory data analysis, which I just showed us, right? So you now start generating insight from your data by using several functions that I've introduced: group by function, correlation function, value count, unique, all of that. Plenty of them that I didn't that you can as well check out. But these are the most common ones that you'll be using most of the time. All right. So this is exploratory data analysis, and you can see that visualization is a very, very important part of EDA, which we are going to be looking at tomorrow. So we're going to be looking at how we can incorporate visualization into understanding and exploring our data. So it's going to be actually very interesting tomorrow. I hope we'll be able to cover everything regarding that in tomorrow's class. So that is it for EDA. And if you're a data analyst, this is usually where you stop in your data analysis task, right? But we are not going to stop here because we are going to be doing machine learning. So we'll continue to the next stage, feature engineering, and then move on to building our model, right? Which we're going to be doing in subsequent weeks. So these are the stages basically that we're going to be following throughout the course of the remaining weeks. All right. So please just have it at the back of your mind. So you have a guide. You have a guide to follow when you are working or doing anything. So that's it for today. I believe we've learned one or two. So we are going to continue from there, from where we stop tomorrow, and we're also going to look at how we can work with date time, right? So we're going to look at how we can work with date time tomorrow, and also how we can incorporate visualizations also into getting or deriving insights from our data. All right, and using new libraries as well. We are going to introduce new libraries to us tomorrow. So yeah, that is it for today's class. I believe we've been able to pick up one or two. All right, we are progressing. We are making progress. We are introducing new things to us. Some of us might feel overwhelmed. All right, which is fine. Which is fine. So you just need to. Everybody has a different format for learning, right? Everybody learns the same way. So just understand yourself. Take your time to go over it again, and trust me, you're going to be fine. All right. So that is going to be it for today's class, and I'm going to be dropping it here and taking questions. So if you have any questions, please let me just indicate by raising your hand, and we're going to be taking you. So I'll just take 5 persons. All right. All right. Israel, Patience, Precious, Tolulope, and Kuma. You guys would be asking your questions. All right. Israel, please go ahead and ask your question. You are on mute now. Israel, you are on mute, sir. You can ask your question.
All right, sir. Thank you so much for today's class. Quite innovative enough and quite enlightening. My question is, being a data analyst over time, whenever I'm trying to do correlation, I used to be specific. So I just want to be so sure that in data science as well, using this code and the method you gave to us, can we be specific as well? Perhaps maybe if I'm trying to do maybe Pearson correlation, or I'm trying to ensure partial correlation, is there any way I can be that specific using codes? And
Okay.
another question on it is, generally, we are always concerned about statistical significance in interpretation. I don't know if this is also relevant here. That's my second question.
All right. I think I get your question. So that is going deeper into statistics. All right. So this is just a casual analysis, a descriptive analysis. You're not
All right,
necessarily trying to make inference
all
or
right,
do
all
inferential statistics. You understand?
right, all right, sir.
So the correlation technique used in pandas is Pearson correlation basically. So that's the correlation used. But if you need to work on specific statistical task, there are libraries that are used for it. So we have SciPy, we have stats model in
All right,
Python. So these libraries, they give you very, very specific control over
all right,
what you want to do. Like anything that you can think of in statistics, you have it there. Even your confidence interval and all of that. So you can perform all of that. But for this is just normal descriptive analysis. There is no
all right,
deep in-depth statistics being done. All right. So
all right,
if
sir.
there's a need for specificity, you can as well look at other Python libraries. You can look at scipy.stats. So scipy
All
has a module called stats, which performs statistics, and also we have another library called stats model, which is for
all
statistics
right, sir.
as well. So yeah, that is it. So what's your second question
Thank you,
again? I
sir.
think I forgot.
And the second one is just the statistical significance. We have
Okay,
to
okay.
look.
I think you should answer that. I think I've answered that because we are not performing inference. We are not
Yes, yes,
making
yes. You answered
inference.
that
We are
already.
all right. All right.
Thank you so much.
I think all right. Okay. Patience, please go ahead and ask your question.
Good evening, sir.
Yeah. Good evening.
Thank you for today's class. Please, my question goes like this. If you have a data frame of about 100 rows and you want to access between, let's say, 45 to 60, what
Yeah.
particular syntax are you going to use? Syntax.
Okay. I think I will leave that for someone to answer that for her. Can someone just answer that in the chat for her? So someone to just answer that. I believe everyone had that question. Can someone just? She asked if you want to access a particular row, right? Maybe from 45 to one particular number. Which syntax are you going to use? I think we did this in the last class, so I need someone to just quickly answer that question in the so as someone is doing that, let's just move ahead to the next person. If nobody answers it, I'll answer it. Okoli Precious, please answer. Ask your question.
Good evening, sir.
Hello.
Good evening, sir.
Yeah. Good evening. Please go ahead and ask your question.
Thank you for today's class. It's actually an interesting class, though very overwhelming. But I believe with time, when I go through it over and over, I will follow through. Then it's not really a question. I want to make an appeal. I want to see.
What do you
concerning my
say?
last. I said it's not really a question. I want to make an appeal to you
What is it
concerning my
about?
last week assignment. I did the
Um,
assignment submitted. Then after you assessed it, after marking and scoring, I discovered I had 1/10.
or what was there any comment?
So I went back to the class. I came to the class. No, there was no comment on it.
Um,
And during the correction, I discovered I had almost everything.
in this particular situation, there's a high probability, or like very very high probability, that you submitted the wrong file or an empty file that has just a question. So that's just, I believe that that's going to be the case here, because there's no way I'm going to score you 1/10 when you had everything. So it's probably you had you submitted a file that was empty. Yeah, I think that should be it.
So, sir, please, is there any way can I resubmit or anything? Ah,
Please, let's talk after. Let's talk outside this class. All right. So we'll sort that out later. So others, we can just wrap up with the class. Send me a DM so we can continue the conversation and see what we can do.
okay.
All right. Tolulope, please ask your question. Hello. Hello. All right. Adeleke Emmanuel. Ask your question, please.
Thank you very much,
Hello,
sir.
sir.
Hello.
Yeah.
Hello.
In the case where we have a variable sex um, in our data set,
Yeah.
so how do we containing male and female? How do we replace male as M, and we have like 1,000 rows?
Okay. Are you asking about replacing the values? Replacing the values in your columns.
Yes, sir.
I think we've looked at that yesterday. I'll be in the previous class. You okay. Let me see if I can quickly demonstrate it. So basically, if you have, let's say, this is your column that has df prod id. All right. Let's say you want to replace you want to replace A, B, C, and D. All right. So I can come here and say dot replace. So this dot replace will actually take in a dictionary if you want to replace more than one. So I'll come here and put A. I'll put first, replace it with first. All right. Come and say B, replace it to second.
Mm.
I come and say C, replace it to third. I come and say, I think we have four. D, replace it to fourth. All right. So basically, this is well, okay. Come here and put this. So this is basically how you replace. So you can see that I've replaced all the values. So in case you have male and female, M and N, M and F, you can just come here and put M. That is the old value, and come here and put male, right? So that is basically how you do the replacements. Is that
Yeah.
is that clear?
Yes, sir. Thank you, sir.
All right.
Yeah, yes, sir.
Okay.
Hello, good evening, sir. This is Lope.
Yeah, Tolope, please just ask a question.
Hello, sir.
Yeah, I can
Yeah,
hear you.
sorry. All right, sir. So, thanks for the class, sir. I really appreciate. So, I have a little issue, sir. I have a little issue concerning installing package on Python because
Concerning,
I also installing a package on Python, installing a package on
mm,
Python. So
mm,
I was trying to do some tasks because I follow some tasks and Python tasks on Twitter. So they gave us some tasks to do every day. So I was trying to install PySiglet. So I discovered that when I press import that PySiglet as so, it didn't give me what I want. So the person was saying I have to first install. So he told me to use pip install Python or something. But I used it, but I didn't get the command for it at all.
is it by using pip to install? Like, where did you install it? Is it in your? Are you do you do it on your Jupyter notebook or on your command terminal,
I used the
command
Jupyter
prompt?
notebook.
Eh?
I used the Jupyter notebook, sir.
Do you put an exclamation mark before the pip, or you just use pip like that?
I just use the pip like that.
You have to put exclamation mark before the pip so it will work.
Okay. Okay, sir. Okay, sir.
Yeah.
Thank you.
All right. Kelvin, I think you'll be the last person to probably call it a day. Kelvin, please ask your question. Hello, Kelvin. We've actually wasted a lot, spent a lot of time, so we can't afford to spend any again. Your hand were up, Kelvin. All right. So that is it for today. So thank you very much for your time. We actually spent a lot of time. I think I'm going to 3 hours now. So we would be continuing from where we stopped tomorrow. All right. The recording for this class will be made available as usual. Your grades will still be um graded. Um so just be expecting that one too. All right. So don't bother yourself and don't worry about it, please. All right, because I know some persons will keep asking about grade and all of that. You'll get it definitely. So yeah, once again, thank you very much for your time and your attention. You can as well as we do usually just drop what you learned in today's class. I believe there's a lot that we discussed. All right, so please just highlight them and I will go through each of them and react, and we will see you tomorrow. Um, enjoy the rest of your day, and good. Thank you very much, and good night.